Hello and welcome. I am still doing this. Okay, so today last time when we left, we were just like structuring this parse PGM function, which is a function that this book told us to implement. Not this book. Man, the organization is just marvelous. So this book, Chapter 10 of Real World Haskell. We are studying this chapter and we implemented a basic parser, and it's like the worst way of implementing the parser, but it works. It has everything. So let me just like recapitulate. So we have like a parse natural function inside this case statement. I mean, of course, this, and we call this on input. Just to recap, to call functions in Haskell, you basically call them as in Lisp, and to call functions in Lisp and in Haskell, you use parentheses. The first thing in the parentheses is called with the arguments that succeeded. So like input, I could have other inputs, and it would be called on all of those. So the parse natural function called on all this input 2, input 3, and so on. So this is how functions are called, and since Haskell is special, you can remove the parentheses and it still works. So where you can do it. That is the most obvious thing I ever said. So then you have the just thing, which is pattern matching. So the case statement, it takes the result of parse natural and it pattern matches it against the just keyword. It pattern matches it here. It has two branches. This case statement has two branches, and this branch, it pattern matches this tuple, which has width and rest, and in this case the parse natural function just returns the next number that is parsed. So we implemented it here or something. Just search it. It turns out we didn't. No, there it is. As you can see, it uses this function, which is basically the same function. Now that I think about it, we could just do this. The parse natural function is just an alias for the L8 read integer function, which is from the L8 library, which just handles byte string operations as if they were valid UTF-8, because we are parsing a PGM format. So I'm just recapitulating because I want to. I will not do this every time, just when I feel like it. So I have like the I'm going to the directory. I actually have a shortcut to do this immediately, but that's that. So if I go inside the assets, you will see that I have like a picture of a lolcat. We are parsing this image, which is in PGM format, which stands for portable gray map format, into this data structure, which is gray map structure. It has a width, a height, a max value, which is basically the maximum amount of blackness that is allowed, and it's not that it is it's not really, it's relative. It corresponds to 1. So this value corresponds to the maximum amount of blackness in a given pixel. And since as an example, let's open this in Vim. So let's open this. Let's do the same thing, but open it in Vim. As you see, you have 255 in the third spot, which conventionally means that the max gray val is 255, and this means that the pixel that has 255 is black, and the pixel that has 127 is gray, like halfway through, because that's half of 255, and this is the maximum. It's basically this scale. And then you have the contents, which is a byte string. So very peculiar file format, because the header is ASCII while the body is byte string. So we need a byte string data structure to store it, because it's a byte string, and but we can interpret the header as ASCII. So this library does exactly that. It's like tailor-made for these things. In this library you can interpret a byte string, which is the input we have, as valid UTF-8. And when we get to the byte string part, we will just, read this single bytes and interpret those, because this part is basically like, here in Vim, I read it as a UTF-8 string, but as you can see, we have like a lot of invalid characters and nonsense, because this is not made to be interpreted as UTF-8, it is made to be interpreted as the amount of grayness in each pixel. So it's like a custom format encoded in a byte string. And we will not interpret this as UTF-8 because we will get nonsense, which is displayed here. We will interpret this as as what it is, as amount of gray. And we will not even do that. We will just stop at the parsing. So we will just take each byte, convert it to an int value which will represent the amount of gray, and put it in a list. In Haskell, you represent the type, which is a list, by taking another type and putting it inside brackets. The brackets are basically a type constructor because they construct the type from another type, and in this case they construct a list type, a list of ints from an int. So that's it. Let's see how we can now make the parser work in a more concise way. Because the problem is that parsers are functions. You have to get used to this, but you get used to this as you write like a lot of parsers. But a parser is just a function which goes from well, this is not like the correct example, but if I have like this should not be here. I have no idea of why this is here. Just ignore that. Yeah, this might be intimidating because it's a lot of code, but it's just well, I might as well explain it since I'm explaining everything. So I have this gray map, which I already explained. It is a record in Haskell. Well, it's basically a structure if you're used to like C or Java, and you have like a new type which we do not need. So let's get that away. This is useless for now. We have the parse natural, which we need. The parse bytes we need. The parse PGM we also need. And so here is the most important function, the parse PGM. It parses the whole thing, and it's called parse PGM because and it takes a byte string and it returns a maybe gray map. So this is basically wrong because it should return a gray map, which is basically its output, and something else, which is another byte string, because a parser is an eating function. It consumes input, so it has to return what it has not consumed. So like here it just like takes an input and it turns it into, it takes an input, which is this, and it turns it into its output, which is really just a gray map, and the other is just decoration, which we need because it needs to return like the other things. Wait, that's not what I wanted to do. The other things, which is it has not parsed. For example, the parse natural, like if we call it here, it will parse the 430 and return the rest, which can then be given to another parser. This makes parsers very chainable. We will, chainable is what we're going to see. So then we have maybe, which wraps everything. Well, of course, we need a tuple to wrap like a multiple return type thing. We have a maybe, which wraps this tuple. Maybe is also a type of structure. It takes the tuple, it transforms it into a maybe of a tuple. And what is a maybe? Well, it makes this into a type which can be nothing, literally, like we have here, nothing. Or it can be whatever this is. So it can be a tuple, but since it's maybe a tuple, it can also be nothing. And this happens when like we parse a number, but we parse a number here, and we have a string, so we can't eat the string, so we just return nothing. And of course, the string without any modifications whatsoever, like the same thing, because we could, give this to another parser if we fail, and all those things. They have a lot of use cases, parsers. So if you make parsers this way, it might seem complicated, but it's like the thing that offers more use cases. Yeah, so this is the parse PGM function, which we use like I just said, and it needs a bunch of other supporting functions, because here it is, we defined it. Of course, you know why it's like duplicated, but here it is, we defined it. We also have a test, it should not be there. Okay. So I have now explained everything. Well, the imports are easy, self-explanatory. I just explained them. And we have the parse bytes function, which I have not explained, and the parse natural, which I still. But these are just other parsers. So the idea is the same. If you get the parse PGM parser, they work in the same way. But instead of parsing the whole thing, the parse nat parses natural. So we will need it for these three, and the parse bytes parses bytes is bytes. We will use it to parse these. We still need this thing, which I haven't defined, but we will get there. And yeah, so we begin with parsing a natural, which of course is wrong because I am most of the times wrong. So I got this wrong too, because we might parse we might get a file that has a lot of these chained together, so we might not consume all of it, so let's return the rest. So here's parse PGM. It accepts an input, it gives it to functions, and it chains them together. So our problem becomes, how do we chain parsers together in an elegant way? Well, not like this, but this is the naive approach, so let's do this first. And I get it wrong because at first I need to parse the header, so I will parse header, and I will parse it on the input, and I will check the branches to see if I have received the nothing, because it returns nothing, but for compatibility I will still have the second element of the tuple represent the rest of the unparsed string, and it returns nothing, so we need to return we need to match on nothing. Why does it return nothing? Because it does not need to output information, it just needs to match this as it is, because by convention we need to see a P5 here, and that tells us that this is the right format. So just this will, in that case we will do all of this. Just use this formatting capabilities of Vim, and in case I did not get anything, this shouldn't be here anymore. We will format it later, so it is not correctly formatted, but we will do nothing in case it does nothing. And I said do nothing, but I mean return nothing. So in case nothing, let's format this first. So I formatted it and it didn't work, of course. So let me see why it didn't work. I will get back. So I basically just erased everything, and it now works. So I can reload in Haskell. If you're wondering how I got here, that's quit. I am inside an stack project, and I explained stack projects in the first video, and you can just do stack GHCI, which is the Haskell interpreter, and it just runs GHCI, but it runs it with all the added things it needs to run smoothly. In the context of your project, it loads the main module, so you can call these functions if you want. We can create a gray map, which is defined here. You can just create it, gray map with a width of 1, a height of 1, a max gray ball of 1, and an empty list, and it prints it because it arrives show and it tries to print. So this is GHCI basically. The book I'm reading has a whole chapter on it. It's introductory chapters. I decided to skip those. I will, read this. So maybe if you want, you can, look at this after you read the intro. Okay, so yeah, I basically erased everything because I'm explaining everything. So let's just do so. I have a very simple main function, hello there. So now I have the parse PGM input, and yeah. So let's write it from scratch. So I first need to basically read the let's bring back the thing. Let's put this in another window, and let's bring back the assets. So okay. So I first need to read the P5, which is basically what parse header does. And parse header does this, and just to explain it, because we could not, well, yeah, it's not. So let's parse the header of the input, and you know, this returns a maybe. So that's the case of, now this maybe is unwrapped by the case statement, and we can match against it. You know, if it returns a just, again, pattern matching is explained thoroughly. So I can match the result of the parse header function call with the input, and if it returns a just value with an empty thing, and you know, the rest of the thing we need to parse, we go on and we do another case, because we call the next parser, which is, you know, the parser that we will need to parse for 3.0, you know. So parse, well, not num, parse natural, parse a natural number, which we will parse from the rest, okay, and we will match this also against the just. In case this does not work, you know, I am now, well, I could do this before, yeah, I think it's much more comprehensible. So this is the other branch of the case statement is nothing. In case nothing matches, nothing happens, I will return nothing, you know, I will stop with the branching, and the value of parse PGM will also be nothing. So this little, you know, yeah, C program for life. Okay, so this little, you know, nucleus, this little core, is how we will parse, is how we will chain parsers, and it's like the most ugly way to do it. You know, it's the naive way, but it does work. So we'll first do it like this, and we will then do it in another way, just to make it comprehensible. So, okay, so now we have the other thing we need to do here, and we need to continue the parsing, okay, parsing, okay, so let's just do it. Okay, so case parse mat, well, it's not input, it's just off, let's see, well, nothing, so yeah, and let's see, if I have adjust, I will have the width. This is the cool thing about pattern matching, and now I have the width in scope, so this can be used later. I collected the width, that's gone. You know, let's just copy this, since it's basically, I can type, so it's basically, oh, that's so good. That is not good. Yeah, if I could just, you know, automatically parse. Let's see if I can parse. Because, you know, if I have adjust, I now have the width. Basically just erased it. And the rest. And I will do things here, you know. See if it, yeah, it does work. Okay, let's erase the comment. Okay, so now here I will basically just copy this, because we need to parse another natural number. So yeah, just like so, and I will add undefined here and format. Why does it not work? It really should work. That's so weird. Yes, like formatted very badly. I want to see why this doesn't work. So I have the nothing. You know, in case I do parse the first natural number, I get the width and scope, and I start parsing the other natural number, which will be this one. And to do that, I have this parse natural, nothing, and let's just see why does it not format it? Oh, now it does. Okay, it's like so confused with the ugly formatting. If you're wondering what I'm doing, I'm just pressing like a shortcut to auto format. It's an LSP thing. If you want to know how to do it, just ask. Okay, so now here I have the case again. So I parsed, you know, the width, parse width. I parsed the height. You know, the only thing that changes is height. You can really smell the, you know, duplication. Parse height. Let's go with here case. Another parse natural, and you know, I will have the nothing, and I will have the just, and I will now get the max gray volume of this and the rest. And let's see, in case it works, I now have the max gray vol inside. I just parsed it, so let's see, parse, you know, max gray vol, and then I have a case here. I can just parse the bytes. Yeah, parse bytes on the rest, and I have the nothing. Oops, I got too fast. Okay, nothing, and let's get the bytes, and we need to pass to parse bytes the amount of bytes to parse. So here you see I can do width times height, because of course it's width times height, and this shows the advantages of having the width in scope and the height in scope. I can just use them as parameters to other parsers, or parsers generators, really, because if you think about it, then this part of the function here generates a parser, which then parses the amount of bytes required by the first argument, and it then parses this. So yeah, you could interpret it like that. Haskell is full of things like this. So you have bytes, and you have the bytes, which is the contents, and the rest. So here I'm really done, So I can just return just to say that I was successful, and I will return a typical parser result, which is a gray map of the things we parsed. So width, height, and you have also the max gray ball, and of course the contents, and this is all we will need to do. Well, not really, I also need to return the rest of the things, so let's also return the rest, and in case it doesn't, I return nothing. So this, after all of these little things, all of these little functions which are chained, the parsers that I have chained are successful. If all of them are successful, I return this, which is the result I need by exploiting all the little things that I have parsed that are now in scope. In case none of them is successful, any one of them, nothing is returned. So this is basically it. This won't work. I'm not, I haven't even done the technical things, like the technical details are not there, skipping spaces, skipping freaking new line. I will add those in a separate video, but let's see if we can compile this. So let's invent an input, for test. So this function, the pack, it just packs a normal string into a byte string. So let's see, like p5, p5, because it will just stop at p5. So let's see if it can, because I'm not parsing the white space. So the parsenet will basically see the white space, get confused, and return nothing. So that's not what I want. Let's see if it works. Okay, so here let's bring up stack GHCI. Okay, alright, so yeah, spelling mistakes. Parse header, of course. Reload. Oh, that's already promising. Oh no, I have another. So parse header. Always read the errors in sequence. It helps. So parse header. Perhaps you meant parse header. Oh, so yeah, sorry. It was. I need to read this. Parse PGM. Wait, let's see. So in the expression parse PGM couldn't match expected type. Yeah, of course it couldn't. I need to print this because the main is type IO, so I need to do some IO. So let's do put str line, and the $sign just means apply this function to these arguments. Well, it means basically like a wall. On this part of the wall, everything is evaluated, and once that's done, this part of the wall comes in, and it's evaluated on all of this as a single argument. It's an utility. Okay. Alright, so first read the thing. Couldn't match maybe with God. Yeah, because if it has a maybe. So let's just see if it has a show function. Maybe it does. It does. If I do main, I get an error because there is still undefined stuff. So in the next episode, we will define the parser helpers, and we will, adjust this so that it works, so that it actually works, adding the nitty-gritty details. We will then follow the book by simplifying it, by exploiting the power of monads and all of that good stuff. Goodbye.